Hello everyone, welcome back to hopefully the last session on assignment problems. What are we going to do today? Well, I've done with all different questions that you can have in an assignment problem. We now come to the institute material or the questions that are there in the institute material. Now, because I have done so many questions and I've covered every type of question, I'm going to discuss the institute questions. I'm not going to do all of them. Doing all of them is your responsibility. And if there is a doubt, put it through. I will solve the doubt. So what I'm going to do is, I think there are around 5 or 6 questions in the institute material. They are with solution. I'm going to run you through the questions and then see what is it that you need to pay attention to, what is it that you don't need to pay attention to in those questions. So broadly, we are going to do institute material, and after that, obviously, we are going to do the paper discussion. Let's begin then without any further delay. So usually the sheet that I distribute in class is a sheet that has all the institute questions in it with the solution. But for assignment problems, I have created a sheet without the institute solutions. I've only created a sheet with questions. But what I'm going to do is now, because we are doing this over video, I'm going to discuss the solution of the institute material. Answers are correct all the time. But like I said, because assignment problem, even transportation problem, the solution is not one step at a time. You do a lot of steps together and then you get the matrix. What they will print is the matrix. So judging your step-by-step solution with their matrix becomes difficult. So what I would suggest is always try to check your final answer, whether their final answer and your final answer matches or not. What I'm going to do is I'm going to run through the questions and then I will pick up 1 or 2 questions at max that might need a little bit of work, so that at least you get an idea as to how the solutions are going to follow. So let's come to the first question in your institute material. And like I said, I also have created a document which I will share with you once we are done with all this. So this question that you see is on page number 62, question number 1 in assignment problems. What does the question say? Well, the question says that 6 men are available for different jobs. Fantastic. So there are 6 men available for different jobs. How many jobs is not told to you, but there are 6 men is all that is told to you. From past record, the time in hours, very important. See, these are the parts that you are going to pay attention to. The time in hours taken by different person for different jobs is given below. So the time that every person takes to do a certain job is told to you. What do you want from me? The table is given. So men 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6. Now I have a request. Please make sure that whenever you write this 1, 2, 3, 4, 5, 6 on the left and the 1, 2, 3, 4, 5, 6 on the top, make sure that you please draw a line after that, because then a lot of times students mistake this 1, 2, 3, 4, 5, 6 and this 1, 2, 3, 4, 5, 6 as a part of the time matrix, and they end up making a mistake. So I would suggest please draw a straight line here, please draw a straight line here, and then continue doing the question so you understand that this is the matrix. Or see, this is men and this is jobs. You are not going to write men and jobs everywhere. So you know what do you do? At the beginning of the question, mention that let M1, M2, M3, M4, M5, M6 represent the 6 men, and J1, J2, J3, J4, J5, J6 represent the 6 jobs. And then instead of writing this 1, 2, 3, 4, 5, 6 and this 1, 2, 3, 4, 5, 6 everywhere, I would suggest write M1, M2, M3, M4, M5, M6 and J1, J2, J3, J4, J5, J6. Again, what do you want me to do? Well, I want you to find out the allocation of men two different jobs which will lead to a minimum operation time. Now, can I ask you one thing? What is given to you? What is given to you is the time taken for every person to do every job. Am I correct? Now it's time. It's basic common sense that time needs to be as low as possible. So I know my objective is minimization. Do they need to tell you that you have to minimize this? No. But it's a good thing that they are also telling you. So you know, back when I was in college, when we were giving questions, we were not told if you were supposed to minimize or maximize. You had to look at the data and judge for yourself if and whether this question is a minimization question or a maximization question. So if it is time taken to do a job, it's obviously the minimum the better, and that is why it's a minimization question. You remember how I solve an assignment problem? The first thing you do is a preliminary check. Check number one. What is your objective? Minimization. Fantastic. Assignment does minimize. Question number two. Is the problem balanced? Well, there are 6 men and 6 jobs. The problem is definitely balanced. Question number 3. Is there a prohibition of any sorts? No, sir. There isn't any prohibition in the table. Neither is there a prohibition mentioned anywhere. Always remember, they might do this. See, at your level, they haven't done it. But I just want you to be prepared. They might do is what? Suppose for man 3, job 5, they will give you an entry of 8. But you know what they will do? They will very slyly below the table mention that due to technical difficulties, due to legal difficulties, due to physical disabilities, M3, which is the third man, cannot work on machine or cannot do job 5. Then you have to make sure that when you write the question, you add that prohibition. Correct? 3 preliminary checks done. So this matrix is good to begin with. Step 1 row reduction, step 2 column reduction, step 3 assignment. In the institute material, there is no question where you get a direct answer. You will not get an answer. You will have to draw minimum of number of lines. You will redesign the matrix and then you will continue. So let's quickly run through their solution, and like I said, some parts of their solution and your solution will be the same. I would suggest do this like we were doing. Step 1 row reduction, step 2 column reduction, and so on. So step 1 row reduction right here, step 2 column reduction right here, step 3 assignment. Now you know what has happened? In step 3 they have assigned. They have realized that they got only 1, 2, 3 and 4 assignments, if I'm correct. Yes? Yes. But they wanted how many assignments? They wanted a total of 6 assignments, which they didn't get. So what I used to tell you is draw a new table and start drawing lines. Because just in case you make a mistake, you can rectify it. And now drawing lines is up to you. Now I know everybody will prefer the direct method, but I would still suggest try the marker row without an assignment. In the marked row, marker column that has a 0. In the marked column, marker row that has an assignment. In the marked row, marker column that has a 0. In the marked column, marker row that has an assignment. Keep doing this and then draw lines through unmarked rows and marked columns. But again, no hard and fast, no pressure. You can choose whatever you want to. So if you notice, they have drawn lines and then they have told you what to do. All the zeros obtained in table 2 are covered by minimum number of horizontal and vertical straight lines shown above. Here, order of the given matrix is 6 and the minimum number of horizontal and vertical lines is 4. As 4 is not equal to 6, the solution is not optimal. Well, I don't do this. What I do is we do the assignment and we write down, since the number of rows and the number of columns is not equal to the number of assignments, optimal assignment is not reached. So what do we start doing? Step 4, 5, whatever your step is, drawing minimum number of lines. Step after that will be redesigning the matrix. You know what they did? They redesigned the matrix and they again didn't get an assignment. If you notice, they again got only 1, 2, 3, 4 lines, 4 assignments. So they again had to redesign the matrix and they got a solution in the last. Why have they drawn lines? What they have drawn lines to show you that Since there are 6 rows and columns, in 6 lines all the zeros are covered, which means there are 6 assignments. But we don't do that. We show 6 assignments and we say this is it. This is my final answer. And their final answer, which is this, is, and yes, so it so happens that this question has a multiple optimal solution and it has 3 multiple optimal solutions. So you are going to get stuck in a loop. You are going to get stuck in a loop which is going to be a 3-way loop and you will get 3 solutions. Question: do you have to show them all the 3 solutions? Not necessarily, unless they mention that if there is a multiple solution, show me the multiple solution. You know what they've done? This is one solution that they have. What they did is, then later, this is the first solution, this is the second solution, and this is the third solution. This is the third solution. After that, they've drawn 3 assignments and they have shown you 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6, and then what is that assignment? So the assignment is changing, but like I said, since it's multiple optimal solution, the least is 22. All 3 give you the 22, which is the least. That is question number 1. Let's come to question number 2. The captain of a cricket team has to allot 5 middle batting positions to 5 batsmen. So there are 5 middle batting positions. What are the middle batting positions? 3rd, 4th, 5th, 6th. What does that mean? Well, what that means is that the first and the second position is decided. The decision left is in the 2nd, 3rd, 4th and 5th position. Sorry, 3rd, 4th, 5th, 6th and 7th position. The average run scored by a batsman at this position is given below. Stop. My question to you is, if you are sending a batsman at a certain order or at a certain place, what will you check? Will you check what position the batsman makes very good runs, or what position the batsman makes very less runs? Well, obviously good runs. Runs is a maximization objective. More the better. So is the question a minimization objective or a maximization? Will you send a batsman to a position so that the total run scored is minimum or the total run scored is maximum? Well, obviously the total run scored is maximum. And does it matter? Yes, the batting position matters. If you know that for years together, Sachin and Ganguly were the opening batsmen for the Indian cricket team. And more often than always, Sachin would always go as the second man, would never open a lot of times. Then later he would prefer going in 3rd or 4th so that it's less of pressure on you. It's everybody's comfort level, and that is why according to your comfort level, you make good and bad runs at different positions, and that is what they have given you. So you have 5 batsmen A, B, C, D, E and 5 positions. Now mind you, the positions start from 3. Go up till 7. Doesn't mean there are 7 positions. There are only 5 positions, 3 to 7. So 3rd, 4th, 5th, 6th, 7th. So 5 positions and 5 batsmen. Okay. Make the assignment so that the expected total average runs scored by these batsmen are maximum. See, what is given to us is the average run scored. All we have to do is make an assignment and tell them where the total average scored by them is the most maximum. So what they've done is, for A, whenever A has played on the 3rd position, they have written down all the runs and taken an average. So this is the average run scored by A on the 3rd position. This is the average run scored by A on the 4th position. This is the average run scored by A in the 5th position, and so on. Obviously, we would want the average to be at its maximum, and they've told us in the question for maximum runs. You didn't have to tell me that. I know that runs have to be maximum. Question number 1. Is the objective minimization? No, it's maximization. Then step 1 is going to be changing the matrix to an opportunity cost or an opportunity lost matrix. Step 2, is the problem balanced? Yes, 5 batsmen, 5 batting orders. Question number 3. Is there anywhere that it mentions that there is a certain batsman who has a phobia or who has, let's say, some kind of a superstition or a ritual where he can't play at that position? Well, nothing like that mentioned. So then there is no prohibition. First step is going to be changing objective, step 1. Step 2 is going to be row reduction, column reduction, assignment. If you get it, fantastic. If you don't, continue. Whatever assignment you get in your final answer will be applied in the original runs table. See, though they don't care what the opportunity cost table is, because that is not something that they gave us. That is something that we found because we couldn't solve the question. So the final answer to maximize the runs will be applied in the original table. So let's run through the solution. The first step, they have written down the question as and how it is. In the second step, they have picked up the most maximum runs. I think the most maximum runs is 60. And then they have said subtract 60 from all the numbers. So they have subtracted 60 from everywhere. Now this is step 1. Step 2, row reduction. Step 3, if required, column reduction. Step 4 should be assignment. But you know what they did? They have done the assignment in this table itself. I would suggest make a new table and do the assignment so that there is no confusion. If you notice, they got only 1, 2, 3 assignments, because there are 3, sorry, they've drawn 4 lines. 1, 2, 3. No, then they've made a mistake somewhere. There should be another assignment. I think one of these 2 should be an assignment. I'm not really sure though. But I think one of these 2 zeros should be an assignment. They haven't written it. But yeah, you can't really have 4 lines with 3 assignments. If there were 3 assignments, then you should have covered this in 3 lines only. Anyway, when you do the question, you will come to know. They have drawn lines, covered all the zeros, and you notice they have marked the 6 here. Correct? God knows why they have marked the 6. The least here is 4. Then you will start subtracting 4 from the uncovered. Leave the single covered alone, and junction you will subtract the least from the uncovered, add it to the junction and leave the single covered alone. And in the second attempt, according to them, you get a assignment. So you got 5 assignments that you require, and that's it. So these are your batting positions. These are the assignments that you got for a maximum runs of 232. Let's move on to question number 3. Question number 3 is a rather interesting question. I like it because, so when your institute puts up an intelligent question, I feel really nice, and I feel that the institute really wants you to learn. But then eventually when you look at the question papers, you realize, oh God, why do they do this? Why do they ask such beautiful questions in the institute material? And then this is what they want to ask in the exam. Anyway, question number 3. Good for us, easier the better. Average time taken by an operator on a specific machine is tabulated below. The management is considering replacing one of the old machines by a new one, and the estimated time for the operation by each operator on the new machine is also indicated. So let me understand this. The average time taken by an operator on a specific machine is tabulated. Okay, what else? The management is considering replacing one of the old machines by a new machine. Okay, so you have old machines, you want to replace one of them with a new machine. Okay. The estimated time for an operation by each operator on the new machine is indicated. Fine. Okay, so this is the table. Operator, 6 operators, and M1, M2, M3, M4, M5, M6 are your old machines, and this new is your new machine. What do you want me to do? A. Find out an allocation of operations to the old machines to achieve a minimum operation time. Fantastic. So you want me to allocate a machine to a certain operator so that the total time to do these 6 jobs or to work on these 6 machines is minimum, obviously, because it's time. And you have to do this for the old machine. You don't have to do this with the new machine. So exclude the new machine for now. Fine. That is question number 1. Question number 2. Reset the problem with a new machine and find out the allocation of the operators to each machine and comment on whether it is advantageous to replace an old machine to achieve the reduction in the operation time only. Wow. So this is an intelligent question. They are saying to include the new machine and find out whether including the new machine is a good idea or not. Because see, what you are doing is you are removing an old machine and putting in the new machine. So you need to first check if the new machine is good enough. Because if you notice, the new machine is taking different times on different machines. So you don't know if including it is going to be a good idea or a bad idea. Like for example, operator 1 is taking more time as compared to any other machine on the new machine. While operator 2 is taking the least, operator 3 is taking the least. Look at operator 5. Operator 5 is taking 12 minutes, while on the rest of the machines, operator 5 takes 3, 4, 5, 7. That's it. But here 12, isn't that a little too much? So this is one very good question where you have to decide whether the new machine is a good idea or bad. We will see how to go about it. How will the operators be allocated to the machines after replacement? Okay, fine. So the first part of the question, is the problem balanced? Yes, because we don't have to consider the new machine. We only have to consider the 6 old machines along with 6 operators. Is there a prohibition? No. Is there the objective is to minimize? Yes. Then done then. This is your question. Then there is row reduction. There is column reduction. And after column reduction, there is assignment. Don't ask me why they have drawn these lines. Even I don't understand. Assignment. If you get the assignment, fantastic. Which according to them they have gotten, then why have they drawn lines? You don't need to bother. So let me tell you this. Look, they have covered all the zeros with 6 lines. If they have covered all the zeros with 6 lines, which means you need 6 assignments. Which means you can get 6 assignments. We don't have to worry about that. We make our assignment. If we get it, fantastic. If we don't, then we go to drawing the lines. Now according to them, in the first attempt itself, they have gotten the solution. Well, good for them. And this is the answer. The B part I don't want to discuss right now. Let's skip it and come to the next question, which is question number 4. What does question number 4 say? Question number 4 says 6 salesmen are to be allocated to 6 sales regions as the cost of allocation of the jobs will be minimum. So what is given to me in the table is the cost of allocation of the jobs. Okay. Each salesman is capable of doing the job at different cost in each region. The cost matrix is given below. So what is given to you is a cost matrix. Okay. What do you want me to do? Find the allocation to give minimum cost. What is the minimum cost? Fine. Question number 1. What is the objective? Well, the objective is to minimize because you only said that cost is given to you. Well, fantastic. Then minimization. Question number 2. Is the problem balanced? Well, yes. There are 6 salesmen and 6 jobs. So the problem is very well balanced. I don't need to worry about it. Question number 3. Is there a prohibition? Well, not in the first question at least. So I can continue. Step 1, row reduction. Step 2, so row reduction, column reduction, assignment, but they've done everything in one. They've improved the matrix, then they've done an assignment and they've gotten an answer with a minimum of 55. Okay. What do you want me to do? Question B. Now suppose the above table gives earnings of each salesman at each region. So what are they saying? They are saying that suppose or assume this table does not represent cost. This table represents earnings. Okay. Then when you say this is earnings, then earnings is more the better, not less the better, which means the objective changes to a maximization objective. What do you want me to do? How can you find an allocation so that the earnings will be maximum? Determine the solution with optimal earnings. So what do? You assume that these are earnings, and if you assume that these are earnings, question number 1, the objective is not to minimize, it is to maximize. So step 1 is going to be changing the objective. How? Select the most maximum profit. I see a 70 subtracted from every other profit. So here, this is your original table. In your original table, oh no, they've already created a loss table. So this is a loss table directly. I thought they've written the original table and then loss. So they've written the loss table directly. After the loss, row reduction, column reduction, assignment. You improve it because you don't get an assignment. Then you assign again. You get an assignment for a maximum earnings of 305 rupees. Fantastic. So up till now, there is not really a problem with the question. Question number C. There are restrictions. So now they are adding a restrictions for commercial reasons that A cannot be posted to region 5 and E cannot be posted to region 2. Write down the cost matrix suitably after imposing the restrictions. So A cannot be sent to region 5, E cannot be posted to region 2. Are they asking you to solve it? No. All they are asking you to do is write down the cost matrix suitably by giving the restrictions. So all they want you to do is write down the cost matrix by imposing the restrictions. They are not asking you to solve it. So here, see, A cannot be posted to region 5 and E cannot be posted to region 2. You notice they've written alpha. Well, they didn't want to write alpha. They wanted to put the infinity sign. But the guy who was typing it had no idea what to do or where to find the infinity sign. So he just put alpha in place of infinity. And just write down the matrix. That's it. They don't want you to solve it. And this question I feel is a little stupid because it could have been a little more intelligent. I'll tell you why. You know what they could have said? They could have said, solve the problem with the restriction. Now what you would try to do? You would write down the restriction and you would start solving the problem. If you do that, I will call you stupid. You know why? This is the cost matrix which you are trying to solve. Haven't you solved it already? Yes. But sir, we solved it without the restriction. I agree. What is your restriction? A should not go to 5, E should not go to 2. Am I right? Go to your original cost matrix solution. Is A going to 5? No. Is E going to 2? No. Then your answer is not going to change. Your answer is going to remain the same, whether you solve it with restriction or without restriction. If this optimal solution had either A going to 5 or E going to 2, then you would have said, I will have to solve and check. Because this solution is not obeying the restriction. If this is already obeying the restriction, why do I need to solve it? So if they would ask you to solve the question, it would be very intelligent because you don't really need to solve the question. Since my without restriction solution does not have A going to 5, A does not feel like 5 is the good option, E does not feel like 2 is the good option. If they don't feel like it's a good option, even if I put the restriction and solve it, my final answer is going to remain the same. If you don't believe me, go ahead and check for yourself and solve it again. You will still get the same assignment. That's it. That is question number 4. Let's come to the next. And that is question number 5. What does question number 5 say? Question number 5 says that 4 jobs are processed on 4 different machines with 1 job on 1 machine only. Resulting profits vary with assignment. So what is given to you in the table is profits, and profits have to be maximized. Okay. So these are 4 jobs and 4 machines that can do the 4 jobs. Fine. Find the optimal assignments of jobs to machines and the corresponding profit. See, this is intelligent. They didn't tell you that you have to maximize. They said, give me the optimal profit. Now you need to understand that profit is a maximization objective. More the better, not less the better. So the first step in this is going to be preliminary check. Question number 1, what is the objective? Well, the objective is to maximize. Hungarian cannot maximize, it can minimize. So I will change the profit matrix to an opportunity cost or an opportunity lost matrix, and then I will start solving the question. Because if I minimize opportunity lost or opportunity cost, I will automatically maximize profit. How will I do that? Select the most maximum, which I think is 42, and subtract from every other. And here you have, they have given you the relative loss matrix. After that, after the relative loss matrix, they have done a row reduction. After row reduction, a column reduction, and after column reduction, assignment. Now, according to them, I don't think they've gotten the answer in the first go, but it's difficult to judge. And then they have created a solution. And if you notice, they have created 2 solutions. Sorry about that. So maybe it's a multiple optimal solution question with 2 solutions. But either way, the final answer is a maximum of ₹99 profit. So that's it. That is question number 5. These are all the questions. All 5 questions, and everything that you will have to do in these questions is being covered by me. So it is you who is going to solve these questions and not me. What am I going to do? What I'm going to do is I'm going to solve 1 or 2 questions for you, beginning with question number 1. And I want to solve it because it's multiple optimal solutions and it is more than 2. So here you are going to see a bigger loop with more zeros. Now if you see there are 3 solutions, which means there must be a loop of 6 zeros. So there will be 6 zeros stuck in a loop which will neither let you assign anyone, neither let you cancel anyone. So I'm ready with my table. Let's begin with the solution. So the question per se is very simple. 6 jobs, 6 men. The time taken by a man to do a job is given to you. They want you to do an allocation. Pretty straightforward, nothing hidden in it. We directly start with the solution. So you are going to say preliminary check. Is the problem balanced? Yes. Objective is minimization? Yes. Is there a prohibition? No. Then let's begin. Step 1, row reduction. Step 2, column reduction. And step 3, assignment. So this is my question. Step 1, row reduction. So what do? We select the least from every row and subtract it from that particular row. 1 is the least. Subtract throughout. 1, 8, 1, 6, 8, 0. Again 1 is the least. 5, 7, 6, 5, 13, 0. Again 1 is the least. 3, 5, 4, 2, 7, 0. Again 1 is the least. 3, 1, 6, 2, 9, 0. Again 1 is the least. So you have 4, 2, 8, 4, 11, 0. 1 is the least. 8, 7, 11, 12, 8, 0. Row reduction is done. Every row has a 0. Well, all the zeros are in the last row, but that's okay. One more thing. They have written 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6 and written jobs here, and they've written machines here. So I don't want to do that. So I would start off. I don't want to waste place. So I would start off by saying let J1, J2, J3, J4, J5, J6 represent the 6 jobs, and M1, M2, M3, M4, M5, M6 represent the 6 machines respectively. Row reduction is done. Let's move on to column reduction. For column reduction, if a particular column does not have a 0, we select the least and subtract it throughout. Not a 0, so 1, 0, 4, 2, 2, 3, 7. 1, so 7, 6, 4, 0, 1, 6. 1, 0, 5, 3, 5, 7, 10. 2 is the least. So 4, 3, 0, 0, 2, 10. The least is 8, 0, 5. Oh, sorry. The least is 7. So 8 minus 7 is going to be 1. I'm sorry. Then this is going to be 6. 0, 2, 4 if I think. 7, 8, 9, 10, 11. Correct. 4 and 1. And 0, 0, 0, 0, 0 and 0. So step 1 row reduction, step 2 column reduction, done. Let's move on to step 3, assignment. So let me mention that also. I have left some space on the side so that I fit everything on one page. So this is going to be step 1, and that is row reduction. Then this is going to be step 2, and that is column reduction. And now step 3, assignment. For the assignment, I'm going to copy the table as and how it is. 0422 37 76 40 16 05 35 710 43 00 210 16 02 41 and lastly 000000. Correct? Yes. So after doing this, we will start with the assignment with a pencil so that you don't make a mistake. Let's begin with the assignment. Row wise, 3 zeros cannot do anything. Row wise, 1 0, mark it as an assignment. Cancel every 0 in that column. Row wise, 2 zeros cannot do anything. Row wise, 2 zeros cannot do anything. Row wise, there was only 1 0 which is already cancelled. Row wise, there is no 0. There was 1 0 which is already cancelled. Let's start doing column wise. Column wise, 1 0, mark it as an assignment. Cancel every 0 in that row. Column wise, 1 0, mark it as an assignment. Cancel every 0 in that row. Column wise, already cancelled. Column wise, 1 0, mark it as an assignment. Cancel every 0 in that row. Already cancelled, already marked or cancelled. How many assignments do you have? 1, 2, 3, 4. So you have 4 assignments. If you have 4 assignments, is optimal assignment reached? No. Optimal assignment is not reached. Why? Because if optimal assignment was reached, the number of assignments would be equal to as many rows and columns I have. Or in other words, M1 has an assignment, M2 has an assignment, M3 has an assignment, M4 has an assignment, M5 and M6 do not have assignments. Well, then I'll have to go ahead and start drawing minimum number of lines. To cover all the zeros, how many lines? 4 lines. How do you know that? Because there are 4 zeros, so 4 lines. Now it's up to you how you want to do, and this question is pretty simple. Why, I'll tell you. So you have the liberty to draw 4 lines. One line will cover this. Line number 2 will cover this. Line number 3 will cover this, and line number 4 will cover this. You are sorted. But if you ask me, I would prefer doing this by doing tick marks or tick marking, because I think that is more effective. It's up to you, whatever you want to follow. So let me get the table behind ready for drawing lines. My table here is ready. I'm going to assign in this one more time and then draw lines. So this is going to be step 4 if I'm correct, and that is drawing minimum number of lines to cover all zeros. Now, like I said, you can do that instinctively also. I'm doing it by the marking, or like I said, you have another option also. So 3 zeros can't do anything, 1 0 mark it as an assignment. And now where I cancel all zeros in that column, you cancel out the column only. Cancel all zeros in that column. Done. 2 zeros can't do anything, 2 zeros can't do anything, done and done. Column wise, 1 0, mark it as an assignment, cancel every zero in that row. 1 0, mark it as an assignment, cancel every zero in that row. 1 0, mark it as an assignment, cancel every zero in that row. Done. 4 assignments. You should have had 6. Optimal assignment is not reached. Let's start the marking. Mark a row that does not have an assignment. So 1, 2, 3, 4 have an assignment. This is a row that does not have an assignment, and this is a row that does not have an assignment. In the marked row, so this is the marked row, mark a column that has a 0. Well, in this row, this is a 0. So this is the column I will mark. Inspection of the first tick is done. In the marked row, mark a column that has a 0. Well, same 0 already marked. So done. In the marked column, mark a row that has an assignment. Well, this is the one that has an assignment. Then mark this. In the marked row, mark a column that has a 0. Is there a 0? No. Then done. Draw lines through unmarked rows and marked columns. So, unmarked rows is going to be the first row is an unmarked row. The third row is an unmarked row. The fourth row is an unmarked row. And marked columns, well, this is the column which is the marked column. How many lines did you draw? 4, because I had 4 assignments. So 1, 2, 3 and 4. Done. Next step, redesigning the matrix or improving the matrix. So step 5. Improving the matrix. What do? Select the least, and the least is 0 in the uncovered. Subtract this from the uncovered, add it to the junction and leave the single covered alone. So 0, 7, 0, 4, 1. This 0 is at the junction. You will have to add 1. 4 will become 3, 6 will become 5, 5 will become 4, 3 will be 2, 6 will be 5 and 0. 2, 4, 3, 0, 0. Junction will become 1. 2, 0, 5, 0, 2. Junction will become 1. 3 will become 2, 1 will become 0, 7 will become 6, 2 will become 1, 4 will become 3 and 0. 7 will become 6, 6 will become 5, 10 will become 9, 10 will become 9, 1 will become 0 and 0 remains as 0. Now, check if row and column reduction is required. Like I've told you, 99.99% of the times it is not required. But just to be sure, what if, remember, see here there is a junction and you've changed a 0 to a 1. So sometimes it so happens that that was the only 0 in that row and you've changed it to a 1. So in that case, that 0 is gone. So you need to recheck. So has a 0, has a 0, has a 0, has a 0, yes and yes. Yes, 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 yes and yes. So every row and every column has a 0. Fine. Then we move on to the next step, and that is assignment. Now I technically should have drawn a new matrix, but I'm not going to do that. Takes up a lot of time. You do that. Let's start the assignment. 1, 2 can't do anything. 1, 0, fantastic. mark it as an assignment, cancel every other 0 in that column. 2 zeros can't do anything, 2 zeros can't do anything, 1 0, fantastic, mark it as an assignment, cancel every 0 in that column. 1 0, fantastic, mark it as an assignment, cancel every 0 in that column. Let's start doing this column wise now. Column wise, 1 0, mark it as an assignment, cancel every 0 in that row. 1 minute. I think I have made a mistake. I didn't cancel out the 0. I'm so sorry. Just give me 1 second. Sorry about that. Row wise, 2 zeros can't do anything. 1 0, mark it as an assignment, cancel every 0 in that column. Row wise, 2 zeros cannot do anything. Row wise, 2 zeros cannot do anything. Row wise, 1 0, mark it as an assignment, cancel every 0 in that column. Row wise, 1 0, mark it as an assignment, cancel every 0 in that column. Column wise, 1 0, mark it as an assignment, cancel every 0 in that row. Done, cancelled, 2 zeros can't do anything, done and done. Row wise, 1 0, mark it as an assignment, cancel every 0 in that column. So if you notice, I wanted 6 assignments, but I only got 5. 1, 2, 3, 4, 5, which means optimal assignment is not reached. And if optimal assignment is not reached, we have to redesign the matrix again. So you notice we have to draw lines twice. Let's continue then. Mark a row that does not have an assignment. Has, does not have. In the marked row, mark a column that has a 0. So in this row, here there is a 0, so I will mark this column. And here there is a 0, so I will mark this column. Cancel it out. In the marked column, mark a row that has an assignment. So in the marked column, this is the row that has an assignment. In the marked column, this is the row that has an assignment. In the marked row, mark a column that has a 0. Well, there is a 0 here. Mark it then. In the marked row, mark a column that has a 0. Well, there is a 0 here. Mark it then. In the marked column, mark a row that has an assignment. This is the assignment. Mark it. In the marked column, mark a row that has an assignment. This is the assignment. Mark it. In the marked row, mark a column that has a 0. There is no 0 anymore. Done. In the marked row, mark a column that has a 0. Well, there is a 0 here, but it's already been marked and inspected. So I'm done. I'm going to quickly repeat this bit once again. Mark a row that does not have an assignment. Well, there is just one row now that does not have an assignment. In the marked row, mark a column that has a 0. There's a 0 here and there is a 0 here. So this column has to be marked and this column has to be marked. In the marked column, mark a row that has an assignment. This is the assignment. This is the assignment. Done. In the marked row, mark a column that has a 0. This is the 0. In the marked row, mark a column that has a 0. This is the 0. In the marked column, mark a row that has an assignment. This is the assignment. In the marked column, mark a row that has an assignment. Well, this is the assignment. In the marked row, mark a column that has a 0. Doesn't have a 0. In the marked row, mark a column that has a 0. Has a 0, but it's already been marked and evaluated. So done. Draw lines through. Unmarked rows. Well, this first row is the only unmarked row. So 1. And marked columns. There are 4 marked columns. So marked column number 1, marked column number 2, marked column number 3, and marked column number 4. Unmarked rows and marked columns. How many assignments did you have? 5. Did you cover all zeros with 5 lines? Yes. Perfect then. Let's move on. Select the least, and the least is 2. If I'm right? Yes. Subtracted from the uncovered, added to the junction, leave the single covered alone. So 0, 7 will become 9 because junction, 0, 4 will become 6 because junction, 1 will be 3, 1 will be 3 because junction. Second row, 3 will become 1, 5, 4 will become 2, 2, 5, 0. 2 will become 0, 4, 3 will become 1, 0, 0, 1. 2 will become 0, 0, 5 will become 3, 0, 2, 1. 2 will become 0, 0, 4, 1, 3, 0. And lastly, 6 will become 4, 5, 7, 9, 0, 0. Sorry. This is my redesigned matrix. Step 1, row reduction. Step 2, column reduction. Step 3, assignment. Because I didn't get an assignment, I did a drawing of lines. But then after this, I need to check whether every row and column has a 0. Has a 0, has a 0, has a 0. Yes, yes, yes. Yes, 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 and yes. Let's start row wise then. 2 zeros can't do anything. 1 0, mark it as an assignment. Cancel every 0 in that column. 3 zeros can't do anything. 3 zeros can't do anything. 2 zeros can't do anything. 1 0, mark it as an assignment. Cancel every 0 in that column. Let's go column wise. 4 zeros, I can't do anything. 2 zeros, I can't do anything. 1 0, I can mark as an assignment. Cancel every other 0 in that row. 2 zeros cannot do anything. Marked or cancelled, marked or cancelled. Let's go row wise. Done. Done. 2 zeros can't touch. 3 zeros can't touch. 2 zeros can't touch. Done. Column wise. 3 zeros can't touch. 2 zeros can't touch. Done. 2 zeros cannot touch. Done and done. If you notice, you will keep going in a loop, but you will never be able to get an answer. You know why? Because this 0 has 2 zeros here and 2 zeros here. This 0 has 3 zeros here and 3 zeros here. This 0 has 2 zeros here and 2 zeros here. Every 0 has a 0 in that row or that column, and that is why you are not able to pick one. And this is where we come to a multiple optimal solution. So let me do one thing. Let me get another table ready where I'm going to do all the allocations in one together. Yes, I have all the tables ready. So what will happen is, no matter what your table is, so this is my first table where I'm getting a loop. No matter how many times you do it, after this you won't be able to solve it. Let me show you again. 2 zeros, I can't do anything. 1 0, mark it as an assignment. Cancel every 0 in that column. 3 zeros can't do anything. 3 zeros can't do anything. 2 zeros can't do anything. 1 0, mark it as an assignment. Cancel every 0 in that column. Row wise done, column wise. 4 zeros, 2 zeros, 1 0. Mark it as an assignment. Cancel every 0 in that row. 2 zeros can't do anything. Done and done. Again row wise. Done. Already marked or cancelled. 2 zeros can't do anything. 3 zeros can't do anything. Done and done. Column wise. 3, 2, done, 2, done and done. 2, done, done, 2, 3, 2 and done. So now you will keep going in loops. If you do this for the third time, I have gotten a table ready, will be the same. Why I have drawn 3 tables, I'll tell you. 2 zeros can't do anything. 1 0, mark it as an assignment. Cancel every 0 in that column. Then there is 3 zeros, 2 0, 3 zeros, 2 zeros and 1 0. Mark it as an assignment. Cancel every 0 in that column, column wise. 1 0, mark it as an assignment, cancel every 0 in that row. 2 zeros, done and done. Done. I think you will again start going in loops. So let me do one thing. Let me zoom out a little so that I can show you, if possible, all the three tables together. Is that possible? Pretty much. Almost there. Yes. Let me unzoom a little bit. Perfect. So now what happens after this? You know why I do three tables? You notice there are three options for a 0, and that is why I drew three tables. Option number 1. What if, because I'm going in a loop, I have to randomly choose. What if I choose this 0? Well, if you choose this 0, you will mark it as an assignment. Cancel every 0 in that column and cancel every 0 in that row. Correct? Now continue. 2 zeros can't do anything. 1 0. Mark it as an assignment. Cancel every 0 in that column. Can I say that leaves you with 1 0? Yes. How many assignments did you get? 1, 2, 3, 4, 5 and 6. Perfect. That is exactly what we wanted. So we'll write down the answer starting with M1, M2, M3, M4, M5 and M6. M1 is going to J3, M2 is going to J6, M3 is going to J1, M4 is going to J4, M5 is going to J2 and M6 is going to J5. This is one assignment. But what I did was I chose the first 0. It's a random choice, no? I could have chosen the second 0. If I would have chosen the second 0, I would have to cancel all zeros in that column and all zeros in that row. Then can I say when I go to the next row, there is just 1 0 left and then there is 1 0 left here. 1, 2, 3, 4, 5 and 6 assignments. How does that go? Again M1, M2, M3, M4, M5 and M6. M1 goes to J3, M2 goes to J6, M3 goes to J4, M4 goes to J1, M5 goes to J2 and M6 goes to J5. This is my second assignment. Let's go to the last one, which is this one. Well, I could have also chosen a completely different 0, which is I could have chosen the third 0. This one right here. If I would have chosen this, all zeros in that column and all zeros in that row would have to get cancelled. Then I would again start done, column wise done, 1 0, mark it as an assignment, cancel every 0 in that row, assignment. 1, 2, 3, 4, 5, 6 assignments. Let's write that down. M1, M2, M3, M4, M5 and M6. M1 goes to J3, that is not changing. M2 goes to J6, that is not changing. M3 here is going to J4, M4 here is going to J2, M5 here is going to J1 and M6 here is going to J5. Now what I need to do is write down the actual cost in that allocation or time, whatever this is. I forgot, I think it's time. So let's write down the time for that particular allocation, we will have to go back to the original table, which flipping is going to be difficult. So let me have this here so that I can write it down, or if I keep flipping, it's going to be a very bad idea. So yeah, I'm directly going to copy it and then come back. So see, M1 going to J3 is 2. M2 going to J6 is 1. And now M1 going to J3 is 2. M2 going to J6 is 1. Is the same everywhere. 2, 1. Also, M6 going to J5. M6 going to J5 is 9, which is also the same everywhere. Correct? Let's write down the remaining. And the remaining is M3 going to J1. M3 to J1 is 4. M4 to J4 is 4. Going to 4 is 3. And M5 to J2. M5 to J2 is also 3. Then M3 to J4. M3 going to J4 is 3. One minute. M3 going to J1 is actually 4. Correct. No problem. M3 going to J4 is 3. Correct. M4 going to J1. M4 going to J1 is 4. And M5 going to J2. M5 going to J2 is 3. Lastly, M3 going to J4 is 3. M4 going to J2 is 2. And M5 going to J1 is 5. Let's take a total. Let's come to the first total. 2 plus 1 plus 4 plus 3 plus 3 plus 9. So 2 plus 1 plus 4 plus 3 plus 3 plus 9 is a total of 22. So minimum of 22 minutes. Next is 2 plus 1 plus 3 plus 4 plus 3 plus 9 is also 22. And the last one here is 2 plus 1 plus 3 plus 2 plus 5 plus 9 is a total of 22. So you notice 3 different assignments but give you the same minimum cost. And this is your answer, which they have also written. And I wanted to do this question because I wanted to show you the multiple optimal solutions. That's it. Let's move on to one more question that I want to do. Let me show you the answer to this, which they have written. So they've drawn 3 different tables and they have given you the answer. Correct? But their final answer is 22, 22, 22, which is time in hours. Please stick to the presentation that they have. I'm not very good at it. Done? This was one question that I wanted to do. The next question, like I said, that I want to do or I want to discuss is that machine replacement question, where there are some 6 machines and you have to add a new one. This is the question. What does the question say? Well, the question says that the average time taken by an operator on a specific machine is tabulated below. So the time taken by a person is tabulated below. Fantastic. The management is considering replacing one of the old machines by a new one, and the estimated time for the operation by each operator on the new machine is as indicated. So here the times are given to you. Question number 1. Find out an allocation of operator to the old machines to achieve a minimum operation time. Okay, that is question number 1. After question number 1, the next question that I want to do, and that's the only one that I'm going to do, is question number 3, the machine question. Now, what part am I going to do? I'm not going to do the first part. I'm not going to do the first part because the first part is pretty simple. All you have to do is take the first 6 machines, old 6 machines and the 6 operators and do an allocation. So here they have it, old machines, with the operators, and they've done an allocation. That's it. This is your answer. What is interesting for me is the second part, and that is what I'm going to do for you. What does the second part say? Well, the second part says reset the problem with the new machine and find out the allocation of operators to each machine and comment on whether it is advantageous to replace an old machine to achieve a reduction in the operation time only. Okay, this is my current answer, or this is my current optimal solution with the 6 old machines. Now they are saying reset the problem with a new machine. So which means that you want me to remove one of the old machines and put this machine in. The question is, which machine should I remove to put this new machine? Well, the answer is none. Because you don't know this machine, new machine, is better than which machine. And that is why you will not remove any machine. You will add a new machine. But sir, I have only 6 operators. If I add the new machine also to the assignment, that will become 7 machines. Okay. Won't you add a dummy operator? Yes. This is what will happen. Listen carefully. If your new machine is better than my old machines, then the new machine will get an assignment and one of the old machines will go to the dummy. Whoever goes to the dummy should be replaced by the new machine. So you don't have to decide which machine to remove to put the new machine. What you will do is you will find a new assignment with the new machine by adding a dummy operator. If one of the real operators gets the new machine, then one of the old machines will go to the dummy operator. Whoever goes to the dummy, remove it because that machine is not as good as the new machine and put the new machine there. But sir, what if the new machine goes to the dummy? That can also happen. But that will happen if your new allocation is more than 17 hours. If adding a new machine makes the new allocation more than 17 hours, then your answer will still remain this even after adding the new machine and adding a dummy, because the new machine will directly go to the dummy. So if the new machine goes to the dummy, answer remains the same. If the new machine is good, then one of the operators will get assigned to the new machine and one of the old machines will go to the dummy. So what are you going to say? What I'm going to say is, let the new machine be M7. They are writing new everywhere. I'm going to write M7. And to balance the problem, we add a dummy operator, and I'm calling the dummy operator O7. So I'm calling the operators O1, O2, O3, O4, O5, O6, O7 and the machines M1 to M7. Let's begin the problem. So I'm going to begin the problem by saying the first declaration, and that is let the new machine be M7 and let the dummy operator be O7. So now the new machine is M7, the dummy operator is O7. I will write down whatever I have. So I'm going to pause this here, or I'm going to come back with the table ready so that we don't waste time. I have reset the question. I have included the new machine. I have not removed any machine. That's not my job. Assignment will automatically, if this new machine is good, it will take it into assignment. And if there is an old machine which is not good, it will go to the dummy. My job is not to remove anyone. Assignment will automatically remove. Let's begin. Step 1, row reduction. So I have step 1, row reduction. I will select the minimum from every row and subtract it from every other row. Subtract it from that row. 1. So 1, 2, 1, 0, 3, 4, 5. Least is 1. So 3, 3, 5, 2, 1, 4, 0. Least here is also 1. So 5, 9, 7, 3, 6, 5, 0. Least here is 3. So 5, 4, 3, 2, 0, 6, 1. Least here is 3. So 4, 0, 1, 2, 1, 0 and 9. Least here is 1. So 4, 4, 5, 6, 7, 0, 5. And the last is a dummy, which will all throughout be 0. If you want, you can keep writing this as new and keep writing this as dummy. It is up to you. Step 1, row reduction. Step 2, column reduction if required. Do you notice that I have a dummy row? I'll never require column reduction because every column will already have a 0. So I will directly move on to step 2, which is assignment. Let me write that down then. 1355, 440, 2394, 040, 1573, 150, 0232, 260, 3160, 170, 4456, 000, 500, 1950. Let's start assigning row wise. Exactly 1 0, mark it as an assignment. Cancel every 0 in that column. Exactly 1 0, mark it as an assignment. Cancel every 0 in that column. Done. Exactly 1 0, mark it as an assignment. Cancel every 0 in that column. 2 zeros cannot do anything. 1 0, mark it as an assignment. Cancel every 0 in that column. 3 zeros cannot do anything. Let's go column wise. 1 0, mark it as an assignment. Cancel every other 0 in that row. 1 0, mark it as an assignment. Cancel every 0 in that row. Can I say all the zeros are either marked or cancelled? Yes. How many assignments did you get? 1, 2, 3, 4, 5 and 6. How many should you have gotten? Well, I should have gotten 7. So optimal assignment is not reached. If optimal assignment is not reached, I will have to draw minimum number of lines. And now this time I'm not going to draw lines by markings. I will show you the markings for people who require. So I'm going to show you the markings only here. I'm not going to draw the lines. Mark a row that does not have an assignment. This row does not have an assignment. In the marked row, mark a column that has a 0. Well, here there is a 0. In the marked column, mark a row that has an assignment. Well, this is where the assignment is. In the marked row, mark a column that has a 0. There is no 0. You are done. Draw lines through unmarked rows. So 1, 2, 3, 4, 5 and marked column 6. That should do the trick. What I'm going to do is I'm going to show you drawing lines in the other method, which is mark and cancel everything out. So I realized that I did not get an assignment. I'm going to draw the table again and start assigning again. But this time, along with the assignment, I will simultaneously draw lines. So let me do one thing. Let me get my table ready with the values. Let's start assigning again. But this time, as and how I assign, I'm going to cancel out that particular row or that particular column. So let's start row wise. Let's start the inspection row wise. Row number 1. Exactly 1 0. Mark it as an assignment. Don't cancel every 0 in that column. Cancel the entire column out only. Next, 1 0. Fantastic. Mark it as an assignment. Cancel every 0 in that column. Row wise, exactly. So this is done. No 0 here. There is 1 0. Exactly 1. Mark that 0. Cancel every other 0 in that column, or rather cancel out the entire column. 2 zeros can't do anything. 1 0. Mark it as an assignment. Cancel every 0 in that column, or rather cancel out the entire column. 3 zeros cannot do anything. Let's go column wise. 1 0. Perfect. Mark it as an assignment. Cancel every 0 in that row, or right now cancel the entire row. 1 0. Perfect. Mark it as an assignment. Cancel every 0 in that row, or rather cancel the entire row out. How many lines have you drawn? 1, 2, 3, 4, 5, 6. Did you have 6 assignments? Yes. 1, 2, 3, 4, 5 and 6. But can I ask you something? If you would have drawn lines here, let me repeat that for you. How would you draw lines? Well, this is how I would draw lines. Mark a row that does not have an assignment. Well, this is that row that does not have an assignment. In the marked row, mark a column that has a 0. This column is the 0. In the marked column, mark a row that has an assignment. Well, this is the assignment. So this. In the marked row, mark a column that has a 0. There is no 0. So we stop here. Draw lines through unmarked rows. What are your unmarked rows? Well, unmarked row is row number 1, row number 4, row number 5, row number 6, row number 7 are unmarked rows, and marked column, there is just one marked column. How many lines have you drawn? 1, 2, 3, 4, 5 and 6. Have you covered all zeros? Yes. How many lines have you drawn? 6. Have you covered all zeros? Yes. But here is where I want to point it out to you that the lines drawn are different in both the cases. Do you notice? Is it wrong? There's nothing wrong with it. No problem. But remember, I told you, there is a better chance of you getting an answer quicker here. So if I redesign this, there's a good chance that I might get an answer. When I redesign this, which I have drawn randomly, there's a chance that I might have to draw lines again. But now can't help it. This is what I told you I will go through in this question. I'm going to draw lines like this. So I'm going to continue in this. Select the least. The least that you see in the entire table is 1. Subtract it from the uncovered, add it to the junction and leave the single covered alone. 0. 1 0, 0 3 4 5, 2 2 4 2 1 4 0, 4 8 6 3 6 5 0, 4 3 2 2 0 6 1, 4 0 1 2. So add 1 3, 1 at the junction. So add 1 2, 0 at the junction. So add 1 is going to be 1, and 9 at the junction, add 1 is going to be 10. 4 will become 3 3 4 6 7 0 and 5, and lastly 0 0 0 junction. So 1 1 1 and 1. We are done with row and column reduction. We are done with drawing the lines and redesigning the matrix. Check if a reduction is required. No, a reduction is not required. Let's start assigning. Row wise, 3 zeros can't do anything. Row wise, 1 0, mark it as an assignment. Cancel every 0 in that column. There is no 0. So there is a chance that we will have to redesign the matrix, because you notice there was only 1 0 which is already cancelled out. This is the problem. There's a good chance that that lining or this drawing of lines would have given me an answer in the next step, but now this is what I chose. So can I do one thing, or can I say one thing now that I've realized that I will have to, and because it takes too much time for me to draw a table and then come back. Can I start doing one thing? Can I in this table only, or can I draw lines in the same table? Let's continue then. Cancel everything in that column. No. 1 0, mark it, cancel everything in that column. Done. 1 0, mark it, cancel everything in that column. 1 0, mark it, cancel everything in that column. 2 zeros can't do anything, column wise. 2 zeros can't do anything. Done. 2 zeros can't do anything. 1 0, mark it as an assignment, cancel everything in that row. Done, done and done. Row wise, 2 zeros can't do anything, column wise. 1 0, mark it as an assignment, cancel every 0 in that row. How many assignments did you get? 1 2 3 4 5 and 6. How many were you supposed to get? Well, I was supposed to get 7. If you are supposed to get 7, optimal assignment is not reached. You will have to redesign the matrix. Okay. So what I'm going to do is, I'm going to clean this and I'm going to draw the lines in this only, because I don't want to draw a new table again. Or you know what, let it be, I'll draw a new table again. So to draw the lines, let me write this down in the new table. Let's begin. Where did it go? Yes. I put the 7th machine. I tried to do an assignment, didn't get it. This is not our lines. I drew lines. I redesigned. I assigned, didn't get a assignment. So I decided to assign and draw lines. 3 zeros can't do anything. 1 0. Perfect. Mark it as an assignment. Don't cancel every other 0 in that column. Cancel out the entire column. Row number 3, nothing here. Fantastic. I hope you realize we will again have to draw lines, because this does not have a 0. Anywho, 1, mark it as an assignment. Cancel the entire column. Done. 1 0, mark it as an assignment. Cancel the entire column. 1 0, mark it as an assignment. Cancel the entire column. 2 zeros cannot do anything. Let's go column wise. 2 zeros cannot do anything. 2 zeros cannot do anything. 1 0, mark it as an assignment. Cancel that row. because you are going column wise. Done, done and done. Let's again start going row wise. Done, 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 done. 2 zeros can't do anything. Let's go column wise. 1 0, mark it as an assignment. Cancel the entire row. This is the second time I am drawing lines. Select the least. The least in this case is again 1. Subtracted from the uncovered, added to the junction and leave the single covered alone. Fine then. Let us begin. 0, 1 plus 1 is 2, 0, 0, 4, 5, 6. 1, 2, 3, 1, 1, 4, 0, 3, 8, 5, 2, 6, 5, 0, 3, 3, 1, 1, 0, 6, 1, 3, 0, 0, 2, 2, 1, 10, and 2, 3, 3, 5, 7, 0, 5, and lastly 0, 1, 0, 1, 2, 2 and 2. Done redesigning. Every row and column has a 0. Start assigning them. Let's start the assignment. Let's start it. Row wise. 3 zeros can't do anything. 1 0. Mark it as an assignment. Cancel every 0 in that column. Do you realize that row number 3 does not have any other 0? You will have to draw lines again. 1 0. Mark it as an assignment. Cancel every 0 in that column. 2 zeros can't do anything. 1 0. Mark it as an assignment. Cancel every 0 in that column. 2 zeros can't do anything. Column wise. 2 zeros can't do anything. 1 0. Mark it as an assignment. Cancel every 0 in that row. 2 zeros can't do anything. 1 0. Mark it as an assignment. Cancel every 0 in that row. Done, done, done. Done, 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 done. 2 zeros can't do anything. Column wise. 1 0. Mark it. Cancel every other 0. 1 2 3 4 5 6 assignments. You should have had 7. Optimal assignment is not reached. I will have to draw lines. I'm going to copy the same matrix again and then this time assign but simultaneously start drawing lines. This is my matrix. Same matrix I have copied. Let's start assigning and cancelling out. 3 zeros can't do anything. 1 0. Mark it as an assignment. Cancel every other 0 in that column, or rather now cancel the column. Done. 1 0. Mark it as an assignment. Cancel every 0 in that column. Okay. Then 2 zeros can't do anything. 1 0. Mark it as an assignment. Cancel the entire column. 2 zeros can't do anything. 2 zeros can't do anything. 2 zeros can't do anything. 1 0. Mark it as an assignment. I'm going column wise. Cancel the entire row out. Then there is 2 zeros. I can't do anything. 1 0. Mark it as an assignment. Cancel the entire row out. Done, done, done. Let's start going row wise. Done, 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 done. 2 zeros can't do anything. Column wise. 1 0. Mark it as an assignment. I'm going column wise. Then cancel out the row. How many lines have you drawn? 6. Obviously there were 6 assignments, so I will draw 6 lines. I will redesign the matrix. How? What is the least? 1. So again the same. Let me draw the table. I have my table ready. The least is 1. Let's begin. 0, 2, 0, 0, 4 plus 1 is 5, 5 plus 1 is 6, 6 plus 1 is 7, 0, 1, 2, 0, 1, 4, 0, 2, 7, 4, 1, 6, 5, 0, 2, 2, 0, 0, 0, 6, 1, 3, 0, 0, 2, 3, 2, 11, and 1, 2, 2, 4, 7, 0, 5, and lastly 0, 1, 0, 1, 3, 3, 3. Check if row and column reduction is required. Most of the time it's not. Let's start assigning. When I start the assignment, 3 zeros can't do anything, 3 zeros can't do anything, 1 0. Mark it as an assignment. Cancel every 0 in that column. There is 3 zeros, 2 zeros can't do anything, 1 0, mark it as an assignment. Cancel every 0 in that column. 2 zeros can't do anything. Okay. Start column wise. 3 zeros cannot do anything. 1 0. Perfect. Mark it as an assignment. Cancel every 0 in that row. 3 zeros can't do anything. 3 zeros can't do anything. 1 0. Mark it as an assignment. Cancel every 0 in that row. Done and done. Column wise done. Start row wise again. 3 zeros can't do anything. 2 zeros can't do anything. Done, 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 done. 2 zeros can't do anything. Let's go column wise. 3 zeros can't do anything. Done. 2 zeros, 2 zeros, can't do, can't do, can't do. Let's go row wise. 3 zeros, 2 zeros, done, 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 2 zeros. Do you realize we are going in a loop? Yes. And this is multiple optimal solution. I'm not going to find all the solutions because again you will have 3 solutions. How do I know? Do you notice that in the first row there are 3 zeros that I have as a choice, or there are 3 zeros here that I have as a choice? So I'm randomly selecting. I'm randomly selecting the first one. If I select the first one, I will cancel this row and cancel this column. Correct? The second one I will assign, and the last one I will assign. So this is my assignment, and my assignment is seven operators, 7 machines. O1 now goes to M1, O2 goes to M4, O3 goes to M7, O4 goes to M5, O5 goes to M2, O6 goes to M6, and O7 goes to M3. Now if O1 goes to M1, O1 M1, let me check what the O1 M1 value is. Well, O1 M1 is 2, if I am correct. What is O2 M4? O2 M4 is 3. What is O3 M7? O3 M7 is 1. What is O4 M5? O4 M5 is 3. What is O5 M2? O5 M2 is also 3. What is O6 M6? O6 M6 is 1. And what is O7 M3? O7 M3 is 0, obviously because it's a dummy. What is the total? Well, the total is 2 plus 3 plus 1 plus 3 plus 3 plus 1 plus 0 is a total of 13. What do you realize? You got a total of minimum 13 when you didn't have the new machine, when you only had old machines. Remember? When you only had old machines, you got a total of 17. Do you realize the new machine is better Because once you introduce the new machine, the 17 is reduced to 13. And didn't I tell you that will happen? But sir, then which machine to remove? Arre, the machine that went to the dummy will be removed. Who is the dummy operator working on? Machine 3. Then remove machine 3 and add machine 7 in that place. That's my answer. So resetting with the new machine is a good idea. We are going to replace machine number 3 with the new machine. Let's see if that is their answer also. So they have set the new machine. Let's see what their answer is. Oh, they've also drawn lines too many times. Yes and yes. So they have found all the optimal solutions. I haven't done that. I've only found one. Here, 13 is the answer, which we also got. So we are correct. And yes, let's come here. From above, it can be said that replacement of an old machine with the new one will result in the reduction of the total operation time from 17 to 13, which is 4 hours. So replacement decision is advantageous as per the solution. So as per the solution, there are 3 optimal solutions. So in the first one, the dummy is going to M3, which is my solution. So they are saying remove M3 and put the new machine in that place, or the second solution, the dummy is going to M1. So remove M1 and put the new machine. Or in the third solution, the dummy is going to M3, which is what we said already. Remove M3 and put the new machine, which is what they are saying. As per the solution 1 and 3 above, machine 3 should be replaced with the new machine. And as per solution, this is solution number 2 that they have written wrong. This is according to 1 and 3. What does 1 and 3 say? 1 and 3 says remove the third machine and bring in the new machine. Solution number 2 says remove the first machine and bring in the new machine. And solution number 3 says M1 should be replaced by the new one. Perfect. That's going to be your answer. So, like I said, this takes a lot of time when I'm trying to explain and do the drawing of the tables. And that is why I'm not going to do any more questions. This is it. The rest of the questions I want you to try for homework. And if at all you need any help, let me know. So, I'm going to stop assignment problems right here. We are going to do one last bit, and that is checking if at all it is asked in any of the question papers. If yes, for how many marks. So let's quickly go to question papers. So let me put everything aside and let me open the paper discussion bit. So here we have the next chapter, and the next chapter I'm calling it 11 is assignment problems. Let's begin with the first question paper, and that is the June 17 question paper. Let's skip through the objectives. Let's come to the descriptive. So no, because assignment problem needs to clearly have a table. No, no, and no. So not asked in the June 17 question paper. Let me put a dash there. Let's go to the December 17 question paper. No, 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 and no. Not asked. Let's go to the June 18 question paper. Objectives, objectives, and yes. Question 4a. What does question 4a say? A blacksmith supervisor is in his workshop is considering how he should assign 4 jobs that are to be performed to 4 of the workers under him. He wants to assign the jobs to the workers such that the average time to perform the jobs is least. Based on the previous experience, He has the information on the time taken by the 4 workers on performing the jobs, and the same is given below. So what have they done? There are 4 workers and 4 jobs. He has asked every worker to do every job multiple times, and then he took an average and he wrote down the average time. Now what do you have to do? You have to make an assignment. Make an assignment by the Hungarian method. Question number 1, what is your objective? Minimization. Question number 2, is the problem balanced? Yes, it is balanced. Question number 3, is there a prohibition? Well, I read the entire question, there was no prohibition. Then I can start solving the question. Like I said, I'm not going to do this for you. So there is nothing else written. That's it. This is all that is written. Like I said, I'm not going to do the question for you. You are going to do it by yourself and get an answer. Step 1, row reduction. Step 2, column reduction. Step 3, assignment. If you get an assignment, fantastic. If not, draw number of lines, redesign the matrix. How you draw the lines is up to you. Row reduction, column reduction if required. Assignment. If you get an assignment, fantastic. If not, you again draw lines. You keep doing this till you have 4 assignments. Once you have 4 assignments, you are now going to write down your final answer. If you notice, the question has been asked for 8 marks. Now, if you remember that day I told you that every mark you have around 1.8 minutes. 1.8 minutes into 8 marks is going to be a total of 14.4. So you have roughly, if I minimize it, you at least have 13 minutes to solve this question. 13 minutes is good enough. So that was one question for 8 marks in the June 18 paper. So one question, 8 marks. Let's go to the December 18 paper. December 18, sorry, yes, let's begin. Skip past the objectives, come to the descriptive. So done, this is not assignment, this is transportation. Done, so no. None of the places is the question asked. Fine. Let's move on to June 19. No, yes. There also it was asked in 4A, here also it is asked in 4A. Fantastic. What is the question? A project consists of 4 major jobs for which 4 contractors have submitted their tenders. The tender amount in thousands of rupees is given below. Find the assignment which will minimize the total cost of the project. See, now when you are looking at it from a person who is hiring the contractors, I want the cost to be minimum. So I will minimize the cost. Each contractor can be assigned only 1 job. Exactly. Now you have to mention this because it could happen, no, that I could give one contractor 2 jobs. He can employ different people to do the jobs. But they are saying no, every contractor will get 1 and only 1 job. Question number 1. Is the problem objective minimization? Yes. Is the problem balanced? Yes. Is there any prohibition that this contract can't go to this particular, this job can't be go to this particular contractor? No. Then I can start solving. Row reduction, column reduction, assignment. How many marks has this been asked for? Sorry. Well, this has been asked for a total of 8 marks again. Right here. Sorry. Total of 8 marks. So let me make a note of that. If nothing was asked in December 18, in the June 19 paper, one question was asked for 8 marks. Correct? Yes. Let's come to the last question paper, and that is going to be the December 19 paper. Skip past the objectives. Descriptive. 2AB, 3AB, 4A, 4B, 5A, no, not asked anywhere. That is it then. Not asked in the last question paper as well. So I'm going to put a dash there. Done. That's it. With this, assignment problem comes to an end. I have done the chapter through and through. Practice the questions in the material. If there's any help that you require, please feel free to ask. Thank you very much. I will see you in the next session.